So what we're talking about today is our multiplicity of zeros. So we're still going to be sketching pictures of graphs. We're still going to be talking about end behaviors, what's the degree, what's the leading coefficient, all that good stuff. But then there's one more step with it to help us finish our pictures off that we didn't get to just yet. So we're going to look at each of our functions. We're going to go through our A, B, C, D up above, and we're going to fill it in. So letter A wants us to figure out how many zeros exist. So if I am looking at my f of x function, how many zeros do we have? 3. Our largest exponent is a 3, therefore we have 3 zeros. B, they want us to now find these zeros algebraically. So we're going to set this equal to 0. And we're going to go ahead and solve it. So do we have a GCF? Yes. We have a GCF of x. And then we have x squared minus 4. Which, how does our x squared minus 4 factor? Good. X plus 2. X minus 2. So our zeros would be 0, negative 2, and positive 2. So now letter C wants to know how many X-intercepts exist. Now your X-intercepts are not always the same as your zeros because they have to be real numbers. So are all of our zeros up here real numbers? Yes. So that means we also have 3 X-intercepts. Now part D wanted us to sketch a picture of it and determine our X-intercepts, but I've already sketched the picture for you. You're welcome. So if you take a look, here are our 3 X-intercepts, also known as our 3 roots at negative 2, 0, and 2, just like we figured out that it should be at algebraically. Keeping in mind, since we had a degree of 3, that means we have an odd degree. So thinking back to last class, our end behaviors are exactly how they're supposed to be, left side down, right side up. So let's go through that notation a little bit. Refresh our memories because that was kind of tricky. So as x approaches positive infinity, so that means you're over here on the right side of your 0. So this is our fancy way of saying the right side of our function. Which way is our graph going? Going up. So our graph is going to positive infinity. So as x approaches positive infinity, this graph is also going to approach positive infinity. So that's how we write our end behaviors now. For our left side, as x approaches negative infinity, so looking at our graph, that means we're going to the left of it. So I'll put in little parentheses there to refresh our memories. That's our left side. Which way is our graph going? No, down to negative infinity. So the function approaches negative infinity. So we practice that because we do have a quiz coming up next class. All right, so let's take a look at the next one. Letter A, how many zeros are we going to have? 4. Letter B, let's find those zeros algebraically. So x to the 4th minus 4x squared equals 0. Do we have a GCF? Yep, what is it? X squared. So we then have x squared minus 4, which we know factors into what? X plus 2, x minus 2. So we would have x equals 0, x equals negative 2, and x equals positive 2 yet again. We have the same zeros as we did last time. But see, what happens is our 0 here, because that was an x squared, our 0 is what we call a double root. So we still have 4 zeros, it's just one of them is a double root. So you only have 3 different numbers. So therefore, for our C, our x-intercept, we have 1, 2, 3 different x-intercepts. So I just do that to show you your x-intercepts don't always have to be the same as your number of zeros. We only actually have 3 x-intercepts, but we still actually have 4 zeros because, as I said, that 0 is a double root. So again, if we look at our graph, there's our roots at -2, 0, and 1. As you can see at the 0, does it actually go through your x-axis? No, that's because your 0 is a double root. It only bounces off the 0 and then it keeps going back down. Now our degree for this one was an even degree. So that means our n behaviors are different. They're both going in which direction? They're both going up to positive infinity. So as x approaches infinity, so our right side, that means the function is going also up to positive infinity. So how would we write for our left side? As x goes to what? Negative infinity, the function goes to positive infinity. All right, let's take a look at our third one. We've got to actually sketch our graph this time. So A, first off, how many zeros are we going to have? 5. Part B, let's find our zeros. So I'm going to set that equal to 0, 5x, or x to the 5th minus 4x to the 3rd. What's our GCF? X to the 3rd. And yet again, we're left with x squared minus 4, which factors into x minus 2 times x plus 2. So what are our zeros? Yeah, we got a 0, a 2, and a -2. So how many x-intercepts again? 3 x-intercepts. So again, it said we could have 5 zeros, but we only have 3 x-intercepts because you got to look at how many times does it actually touch or cross your x-axis. So let's sketch our picture. So I start off with my dots at my -2, my 0, and my 2. Now, this is an odd degree. Our leading coefficient is positive, so which way should our n behaviors be going? N behaviors, right side should be doing what? Up. And our left side should be going? Left side should be going down. Your odd, it means that they're going opposites. One's up, one's down. So now what's going to happen is all of these are going to cross through your x-axis. Remember how our 0 here on this last one, it only touched it? And that was because it had an even exponent on it. Do any of these have an even exponent? No. So those are all going to go through your x-axis. So our left side is going to start down, and I'm going to go up and hit my -2, curve back around, go through my 0, and then loop back up so that my right side's going up. And since it's a sketch, we don't actually know if my max and mins are 100% correct. They probably aren't, but that's okay because it's just a sketch. We're just looking at our roots there. No, this one's also an odd degree. Where? Oh, EV, end behavior. Yeah. I meant meant to write n behavior over here. So our new thing, our multiplicity deals with those exponents on your roots. So up here, when I factored this out, all of my exponents are 1. So since they were all odds, it all went through the graph. It went through the graph at -2. It went through your x-axis at 0. Went through it at +2. Anytime you have an even, that's when it's just going to touch at that number. So odds, it crosses the x-axis. Evens, it's going to touch. And that's the whole point of our multiplicity that we're talking about today. So let's take a look at the back. So the multiplicity factor, which they use the letter K to represent, that means how many times that 0 is repeated. So if it's a 2, that means it's repeated twice. If it's a 6, that means it's repeated 6 times. So if K is odd, then the graph crosses the x-axis at whatever that root is, whether it's a 2, a 5, a 4. If K is even, the graph touches at whatever that number is. So we're going to put it all together here. We got 2 examples. So when you're sketching your graphs, you have to make sure you look for all of these things. You got to first look at what is your degree and what is the sign of your leading coefficient, because keeping in mind those 2 things determine your n behaviors, which you need in order to get your sketching done. You then determine your number of zeros and your number of possible extremas, which would be your maxes and your mins. After you figure out how many you should have, you then go ahead and you find them. Determine your multiplicity factor, how many times is each 0 actually used, and then you can sketch your graph. So let's go through our little list down here. So example 1, let's start with our degree and our leading coefficient. So what is our degree of that polynomial? 5, because our largest exponent is a 5. This is a degree of 5. What is our leading coefficient? -2, whatever that number is in front of your first term there, that's your leading coefficient. So it's an odd degree, so I know, and hopefully you know, that means your behaviors, one should be up, one should be down. It's a negative, though, leading coefficient, so that means my left side needs to be up. My right side's going to be going down. If it were a positive leading coefficient, it would be the other way. Left side would be down, right side would be up. That's just something you got to memorize. That was off of our day 3 stuff. Because it's odd with a negative leading coefficient, it's left, up, right, down. It's just something you got to memorize from day 3 notes. All right, so next we're on to determine your number of zeros. So how many zeros are we going to have? 5. It's the same as your degree. That's how many zeros we're going to have. That's when they specifically ask you to write it. I'm just determining it so I can sketch my graph so I can write it that way now. But if they specifically in a question want you to write out what is your n behavior, not so that you're determining your graph, but because they actually want the notation, you have to write it out the other way. Yeah, so for my left side, I would do x to the negative infinity. Then, let's see, g of x is going positive. My right side would be x approaches positive infinity. G of x approaches negative infinity. All right. Back to our extrema. Now, for your extrema, I did talk about this a little bit in our last page, or last day of notes. It's whatever your degree is minus 1. So the most number of extrema we could possibly have is 4. That's not saying we're definitely going to get 4, but we could have at least 4 maxes and mins within this problem here. All right, next one. find our zeros. So we're going to take our polynomial, set it equal to 0, and we're going to start factoring. Do we have a GCF? Yes, what is it? Negative 2x cubed. Then we have x squared minus 6x plus 9. So then how would x squared minus 6x plus 9 factor? Signs would be the same, right? Both negative. What multiplies to give us 9? And 3 and 3. Now, what is another way I could write this since it's the same thing? X minus 3 squared equals 0. I write it that way to help us with our multiplicity in a second. So here I would get x equals 0. Over there I would get x equals 3. Those are my two zeros. I want to put them up here on my little table. Again, your multiplicity is whatever your exponent was on it. So on my x equals 0, if I look back up here, my exponent was a 3. So my multiplicity was a 3. What was the exponent on my x equals 3? 2. So my multiplicity was a 2. So then again, odds cross through your x-axis. Evens touch your x-axis. Whatever the exponent was when you factored it. So here my exponent was a 3, and my exponent was a 2. All right, so I'm going to set up my axes. I'm going to put dots on my 0 and my 3. So just kind of reviewing all of our information we've written down. We know that the left side has to be up. So I'm going to start this side up here. My right side needs to end being down over there. It's going to cross through at 0, but it's only going to touch my graph at 3. All right, so then I'm going to start. So my left side is going to be going up. It's going to come through, and I'm going to cross through at my 0. And then what I need to do is I got to round it out somewhere so that it comes back up to my 3, and it touches it, but then it goes back down. And that would be the sketch of our graph there. Hmm? All right, let's try our last one here. So let's start with our degree. What's our degree this time? This one's a little different because this one is in factored form already. So our degree would be 1 plus the 2. So our degree would be a 3. If it's in factored form, you just add your exponents together. That's your degree. Our leading coefficient would be negative 1 times 1. So our leading coefficient would be a negative 1 there. So that means I have an odd degree. My leading coefficient is negative, so the left side will be going which way? Up or down? Up. Right side will be going down. How many zeros can we expect to find? 3. And our number of extrema would be 2. You just take your degree and subtract 1. That's going to be your number of extrema. Again, those are your maxes and mins. In our last problem, we said we would have at most 4. We only ended up with 1 minimum in there, and 1 maximum, so we ended up with 2. Yep. All right, next step. We got to actually find what our zeros are. So Negative x plus 5 times x plus 1 squared equals 0. This part is very helpful. They've already factored it for us, so we just have to set each one of them equal to 0. So I would get an x equals 5 and x equals negative 1 as my two zeros. What's our multiplicity on the 5? 1. And on the negative 1? 2. Good. Whatever those exponents are. So since this one is a 1, that means it's going to cross. Since that one is a 2, that means it's going to touch. All right, we got all of our information now. So let's go over here and make our axes. So I'm going to put a dot at my negative 1. Put a dot at my 5. So like our last one, the left side should be coming from up above, and it's going to cross through my axis at the negative 1. And then we're going to have to loop it up. So we're going to come down here, cross through at our negative 1, loop up, touch at the 5, and then go back down. Well, there's no exact spot. You're just kind of, it's a rough sketch. We're not being exact here.